Hello everyone. This video is to show you how to transfer assets of an OEP4 contract. First of all, let's look at the cross-chain contract overview. The ontology cross-chain contract includes multiple contracts. For example, if DApp developers need to realize cross-chain interaction between chain A and chain B, they will need to deploy smart contracts on chain A and chain B respectively. The development of the ontology cross-chain contract can be divided into two parts: the smart contract and the cross-chain. For the smart contract, it refers to the logic codes running on a particular chain, which are developed according to the standard smart contract development methods and are used to complete the contract on the chain. When two chains need to interact, if the logic of chain A has already been executed, we will need to execute the logic of chain B, then the cross-chain interface will be required. For cross-chain contract, developers only need to focus on one cross-chain interface, that is, the create cross-chain transaction interface of the cross-chain management contract. Let's imagine if a developer wants to issue assets on chain A and chain B, but he also wants to have the assets on chain A and chain B to be freely transferred, then he will first need to download the OEP4 contract template. Smart contract A is deployed on chain A, and 1 billion tokens are given to a particular owner address by calling init method. Smart contract B is deployed on chain B, and 1 billion tokens are given to the address of smart contract B by calling init method. To transfer assets of smart contract A and B between chain A and chain B, a lock and an unlock interface are required on the basis of the OEP4 standard interface. The user calls the lock interface on chain A to lock up the assets in smart contract A, and the interface then calls the cross-chain management contract to invoke the unlock interface in smart contract B. The unlock interface then releases the assets in smart contract B to the user on chain B, and vice versa. So here you can see a sample code for calling lock interface. Let's look at the parameters first. So the fee here refers to the minus fee for cross-chain transaction, and toChain ID means the chain ID of target chain. Destination contract is the reverse target contract address. The address here is the caller's address from which minus fee is deducted. The amount refers to the amount of asset to be transferred. As can be seen, the interface first executes the transfer action to lock the user's assets on chain A, and then calls the create cross-chain transaction method in the cross-chain management contract, which accepts 6 parameters: fee, address, toChain ID, destination contract, function, and input bytes. The method will call the target cross-chain contract address method, and the input parameters are input bytes. So here you will see a sample code for calling unlock interface. The interface accepts input bytes as input parameters and deserialize input bytes into input map, and then execute the subsequent logic and unlock the assets on chain B to the user. Please note, this method can only be called by the cross-chain management contract. Currently, the return value of cross-chain methods only supports Boolean data type. So you will find a link for the templates of smart contract A and B here. Let's open it in a new one. Okay, so we open the OEP4 contract, and then you will see contract A and contract B. So we have it here, contract A and contract B. So we're going to use SmartX to create and run a project. It's very easy to use. We strongly recommend you to do that. So now we enter our first smart contract name, contract A. And then we copy the code in the smart contract A to the project we just created into contract A. Okay. Let's leave it for now, and then we create another project, contract B. And then we copy the code from smart contract B templates to the contract B project we just created. So what we're going to do now is to copy the wallet address, my Cyano wallet address, and update it here as the owner address. Then we change the name to t-token0 and the symbol to TT0. So this is the contract A we just created. And then we compile it. We open the Cyano wallet again and check if we are on the correct chain. Then click on next. Then we just enter 1 here. It's just a random figure. Then we deploy it. Confirm and enter your passwords. Okay. So now we will have a transaction hash here, and then we run the init function. Confirm passwords again. Okay. So now we copy the contract hash into our OEP4 tokens. We already had one before, so we can add one fresh and new. And then we save it. And click on the address. You will see 1 billion token here, OEP4 token. So I don't know if you noticed or not, this one was deployed on the main chain with the IP address 125. So now we change it to sidechain 193 and then save. Then we click on the wallet address again. We didn't see any OEP4 tokens. So we're going to do the same for contract B. Update the wallet address and then change the name to TT token 1 and TT1 for the symbol. And we compile it. And then we go down, click next, enter figure in, and then deploy it. Confirm passwords. Okay, then we run the init function. Run. Confirm and passwords again. Confirm. Okay. Now we copy the contract hash into our OEP4 tokens. So we're going to have TT1 token showing up here. And we'll click on the wallet address. We didn't see any 1 billion token in here. So what we're going to do is we run the set destination function, then copy the transaction hash. Use the tool here to reverse the transaction hash, and then copy it into smart contract B. Please note there will be 2 extra spaces here, so we have to delete it. And then confirm password, and then confirm. So this is a way to prepare for the free transaction between 2 projects from main chain to side chain. So we're kind of linking contract A with contract B. And then we do the same for contract A, and we have the So you reverse the contract hash of contract B, and then copy it, paste, and delete the extra space, and then run. You confirm, and you enter the password, and confirm. Okay, so then you can see we have 1 billion tokens on our account, on T token 0, and we're going to run the log function. So we enter 1 as a fee, and to chain ID 1, address, and then copy our address again, and paste. Amount, let's say 1,000, and then we enter 8 zeros because the decimal is 8 here, and then we run it. Confirm password. Okay, you will see there's a change in the amount of token we have in TT token 0. So 1,000 was missing. Where did it go? Now we change it back to the sidechain. And then click here. Oops. It might take a while for the amount to be transferred. Okay, now we got that 1,000 TT token 1. It's actually originally TT token 0, so we just successfully made a transfer from smart contract A to smart contract B. Now we're gonna do a transfer from smart contract B to smart contract A. So we enter the fee and the chain ID into 0, and address, so wallet address, copy and paste, and then we choose into amount, let's say 500, and then we enter 8 zeros because the decimal is 8, and then we run it, then confirm. Passwords again, confirm. Let's refresh it. So now we have only 500 TT1 token in the sidechain. So let's check our main chain, see if the 500 arrives. Save. Okay. Again. As I explained in previous videos, that it might take around 30 seconds for the fees to arrive because the miners' fees need to be synchronized. So be patient and keep trying. Yes, we got it this time. So we have successfully transferred 500 tokens from smart contract B to contract A by using the method we just introduced earlier. So this is all for today's tutorial. For more details, you can click on the tutorial link and just follow through the document. If you have any questions, just let us know.